Hello. In this video, I'm going to talk about a Node.js project dependencies and semantic versioning. So here is an Angular project. And under my Angular project, you will always find this package.json file. This is found for any Node.js project, not just the Angular. The backend, you also have a package.json file. So this package.json file tells what packages are needed to run your package. The dependencies. We have dev dependencies. There's also sometimes peer dependencies if you want to consolidate your dependencies. So I depend on package. I need a package 1, but package 1 is not installed at my own node modules folder. It's installed in my parent's node modules folder. That's called peer dependencies. Whoever consumes me provides me what I need. But let's focus here on dependencies and dev dependencies. So dev dependencies are packages that are needed during development. You're a human developer. You write your code. You need Angular CLI to make your development much easier. And you generate component. One line of CLI commands will create 5 files for you to make sure the process much faster. You also need the test, like comma, for testing. And you need TypeScript to compile your TypeScript files into JavaScript files. So all these things are needed during development. During runtime, once your app is finished, you compile it, you only need these guys, the dependencies, to run your project. So each package have a bunch of dependencies and dev dependencies. And these dependencies and dev dependencies are NPM packages themselves. These are the Node.js packages themselves, and they have their own dependencies. So for any Angular project, or a Node.js project, you will have a tree structure of dependencies. I depends on my children, and my children depends on my grandchildren, and so on and so forth. So how does a Node.js project handles dependencies? Through semantic versioning. So if you look at this Angular namespace, so obviously animations is a very common word. You may have animations package for Angular, you may have animations package for something else. So in order to avoid name conflicts, you have namespace called @Angular. This Angular is a namespace. For Angular, there's animations project, and this animations package it requires is version 20.3.9 with this caret symbol. The caret symbol locks the major version. So you can have a different minor version or a patch version. So for this Angular animations package, I can use version anything greater than version 20.3.9, greater than or equal to, and less than version 21. So for animations package, you can use version 20.4.9, 20.6.5, or whatever. You can change the minor version, you can change the patch version as long as it's higher. So version 20.4.0 works. Anything higher than 20.3.9, that's less than version 21, will work. And the tilde is slightly different. The tilde locks the major version and the minor version. So only version 0.15.2, 0.15.3, 0.15.4, anything before 0.16 will work. So we have tilde, we have caret. The caret is more often encountered because it locks only the major version, but the tilde locks major version and minor version. So for semantic versioning, the last digit number is called a patch. You fix some bugs. Everything else is the same. All the APIs are the same. The package exports the same function, same class, same objects. Nothing has changed. Some bugs have been fixed. The minor version means there's additional things being exported. You export function 1 in version 20.3. In version 20.4, you export function 1 and function 2. There's something additional being provided, but there's no breaking changes. Anything that works with version 20.3 will work with version 20.4. Those bug fixes does not impact your package. Now, the major version always introduce breaking changes. For example, version 21 of Angular animations will not be compatible with packages that consumes version 20 because the API has changed. For example, I used to export a function called add that requires 2 numbers as arguments. Now I export the same function called add Now it requires 3 numbers. All these 3 arguments are mandatory. The syntax, the signature of the function has changed. It requires 2 numbers, now it requires 3. And if you consume the same function, you pass it only 2 numbers, you got an error message because now the function add requires 3 numbers. So that's a breaking change. That said, say I have a package called ngx markdown that requires Angular version 20, and now Angular has upgraded to version 21. And when I run npm install, I got an error message. No, there's a conflict. Your package ngx markdown requires Angular version 20, but now you're installing Angular 21. Does that mean if I install Angular 21, my ngx markdown will break, will no longer work, because breaking changes have been introduced? Not necessarily, because the Angular 21 may export 100 APIs, the functions, classes, objects, and ngx markdown consumes only 5 of the 100 APIs. And the 5 consumed APIs never changed. Nothing has changed. It's something else changed among the 100. So your ngx markdown version 20 will still work with Angular version 21, despite Angular 21 is not officially supported. So you run npm install, you got an error message because there's a conflict. Your ngx markdown cannot consume Angular version 21. But you force install the Angular version 21, your project will not break. Everything still works smoothly. So even if you get an error message, you can still install all the packages to the latest level, and there's no issue. A lot of times there's no issue, even though there's breaking changes being introduced. In theory, your package no longer works, but in practice, the APIs that your package consumes didn't change. Everything still works. So you can force install to the latest version without having to risk any breaking changes. Obviously, you need to test this out. This is kind of non-conservative approach, but I have done this many times. Just force install and everything still works. Now I'm going to introduce a function called, let's get print working directory. Okay, I'm under this Serenity project. I have cd into client. That's my Angular project. Now, under my Angular project, one command I want to introduce is called npm list. Let's list one package called PicoMatch. Okay, you can see here the package PicoMatch is being used at different places. So this is where version 4.03 being used twice. PicoMatch 2.31 being used. And you also see the PicoMatch 4.0.3 has deduped after it. So what does this mean? It means that this PicoMatch package is being used by a lot of other packages. And when deduped appears, it means that, oh, because all these guys require the same version of PicoMatch, I install only one version, and they share the same version. That's why the deduped is displayed. Despite the fact that this fdir package requires PicoMatch version 4.0.3, it's not installed. It shares the version. There's only one version of PicoMatch 4.0.3 being installed. They share the same version. Okay, we actually got a comma package have invalid warning. Okay, let's look at another package. npm list tslib. The tslib is being used by many different packages, and a lot of times you see deduped because they all require version 2.8.1. Only one version of the tslib is installed. Everybody else is deduped. So only one version of the root Node modules folder, you will have a single copy of the tslib. Everything else is deduped. So this is called flattening. So if package 1, package 2, all the way to package 10 requires the same package called tslib, and there's one version of tslib that meets the needs of all the packages, it will install just one copy. Here, let's go to the client directory, node modules. Let's scroll down. You can see there's only one copy of tslib installed, which is tslib version 2.8.1 for everybody. So there's no need to install the package many times. version 2.8.1 here. So everybody needs me, so I just install one copy, and everybody share the same copy under the root Node.js modules directory. So we don't have to install the tslib library like 10 times. Next, let's go to the node modules of the root directory and to find some, just give you one example. Say under the Angular namespace, there's animations. Let's see, the animations package have its own package.json file. So the package.json file is nested, and it has a kind of a dependencies called version tslib, version 2.3 or higher. That's why a single version of tslib 2.8.1 is installed, because it meets the requirements of all these guys. So you can see, to summarize, for any Node.js project, you will have package.json file, and then you have Node modules file have its dependencies installed. And if many packages require the same module, a lot of times there's deduplication. We do not have the nested node modules have the same tslib installed like 10 times. We have a single copy of tslib at the parent level that everybody can share. This is how Node.js project handles dependencies. Now let's talk about package.json versus package.lock.json. The package.json, as I mentioned in the semantic versioning, you can have a range of packages being installed. You do not have to install any specific version. Oh, this is AngularJSON, I apologize, the wrong file. So for example, here the Angular version 20.2.10, this caret symbol, you can install 20.3, 20.4, it does not matter. But the package.lock.json specifies actually, okay, here, yeah. The package.lock.json actually specifies exactly which version has been installed. Despite the fact that I can install either 20.210, 20.211, 20.212, the exact version is being installed is 20.210. So the package.lock.json has exactly which version is being installed. So this package.lock.json has to be version controlled. You have to keep a record of the package.lock.json because this file has exactly the version being installed. And if you screw up, you can just delete the node module files, npm install, and it will reinstall all the packages in this package.lock.json file, so you can get your project back. Okay, so this is my video on Node.js project package dependencies. I want to mention at the end is that when you upgrade your packages, there's not a single npm package that will automatically check for dependencies and make sure that everything's compatible. So the npm install has some quirks. I will use, in my next video, I'm going to use an Angular project and example to show you how to upgrade your Node.js project. Thank you for watching. Bye.